This is SpaceTime, Series 27, Episode 105, for broadcast on the 30th of August 2024. Coming up on SpaceTime, discovery of the heaviest antimatter hypernucleus ever created, a spectacular rocket engine explosion at the United Kingdom's new spaceport, and we look at why food tastes bad in space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Physicists with the STAR collaboration have for the first time ever observed a new antimatter hypernucleus known as anti-hyperhydrogen 4. The new particle was created at the US Department of Energy's Brookhaven National Laboratory's RHIC relativistic heavy ion collider. The experiments, reported in the journal Nature, represent the most massive antimatter hypernucleus ever discovered. It's an important scientific advancement on our journey to try and understand one of the most basic questions of the universe. There's almost no difference between matter and antimatter other than their electrical charge. See, current physics assumes that the properties of matter and antimatter are symmetrical and that equal amounts of both matter and antimatter were created at the birth of the universe in the Big Bang 13.8 billion years ago. However, there's a problem. You see, matter and antimatter annihilate each other when they come into contact. And so the universe and everything in it should have quickly disappeared in a blinding purple flash of gamma radiation microseconds after it formed. Yet for some reason, it clearly didn't, and we live in a universe full of matter rather than one full of antimatter. And scientists have no idea why that's the case. Some physicists speculate some mysterious physical mechanism caused annihilation of most of the matter and antimatter, but for some reason 1 in 10 billion matter particles survived. And it's these particles which form the matter universe we see today. In today's matter-dominated universe, antimatter is extremely rare because it is easily annihilated by surrounding matter. Artificially producing antimatter is difficult. Producing antimatter nuclei and antimatter hypernuclei, formed by combining several antibaryons, are even more difficult to make. Since the Dirac equation indicated the existence of antimatter in 1928, scientists have discovered 6 types of antimatter hypernuclei over nearly a century. And this is where the relativistic heavy ion collider at Brookhaven comes in. It's designed to accelerate heavy ion particles in beams to nearly the speed of light, and then make them collide. These collisions are meant to simulate the sorts of conditions that existed in the early universe shortly after the Big Bang. They produce fireballs with temperatures of several trillion degrees, which contain approximately equal amounts of matter and antimatter. As the fireball rapidly expands and cools, some of this antimatter manages to escape annihilation with matter and can therefore be detected by the star detector. Anti-hyperhydrogen 4 is composed of 1 antiproton, 2 antineutrons, and 1 anti-lambda hyperon. Lambda baryons are a family of subatomic hadron particles containing 1 up quark, 1 down quark, and a third quark from a higher flavor. A hyperon is a baryon containing 1 or more strange quarks. These are the ones of the higher flavor we were just talking about, but no charm, bottom, or top quarks. Due to the presence of the unstable anti-lambda hyperon, anti-hyperhydrogen 4 decays after travelling just a few centimetres. After analysing experimental data from approximately 6.6 billion heavy ion collision events, the authors were able to reconstruct anti-hyperhydrogen 4 from its decay products, anti-helium 4 and a pi meson, identifying a signal for around 16 anti-hyperhydrogen 4. The pi meson, or pion for short, is the lightest meson and an important component of cosmic rays, existing in 3 forms based on charge. The authors were also able to measure the lifetime of anti-hyperhydrogen 4 and found no significant difference when compared to that of its corresponding matter particle, hyperhydrogen 4, further verifying the symmetry between matter and antimatter properties. This is SpaceTime. Still to come, a spectacular rocket engine explosion on Britain's new spaceport, and we look at why food tastes so bad in space. All that and more still to come on SpaceTime. A first-stage rocket booster has exploded in a spectacular fireball during a hot fire test at Britain's new Saxe-Vord spaceport in northern Scotland. Damage to the launch pad was minimal and no one was injured in the blast on the remote island of Unst. The booster was being tested by the German rocket manufacturer Rocket Factory Augsburg, which hopes to undertake Britain's first vertical rocket launch into orbit from the complex later this year. The failure comes 3 months after the company carried out a successful engine test at the same site. Saxe-Vord is the first licensed vertical spaceport in Britain. This SpaceTime. Still to come, why food tastes so bad in space. And later in the science report, a new study reports that 5% of people are consuming products that are potentially toxic to their livers. All that and more still to come on SpaceTime. A new study may finally help explain why astronauts are constantly reporting that their meals taste bad or at the very least bland in space. The findings, reported in the International Journal of Food Science and Technology, examine common food aromas and could help improve not just the nutritional intake for crews in space, but also the diets of isolated people here on Earth, including those in nursing homes. Previous research had already shown that aroma plays a big role in the flavour of food. So, scientists decided to test how people's perception of vanilla and almond extracts, as well as lemon essential oil, changed from the normal environment on Earth to that of a confined setting such as the International Space Station, which for these tests was simulated for participants with the use of virtual reality goggles. The study's lead author, Julia Lowe from RMIT University, says participants found that both vanilla and almond aromas were more intense in the International Space Station simulated environment than under normal ground conditions. However, they found no change in intensity for the lemon scent. The authors found a specific sweet chemical in the aromas of vanilla and almond called benzaldehyde could explain the change in perceptions, in addition to an individual's sensitivity to a particular smell. Lowe says a greater sense of loneliness and isolation may also be playing a role. This is the first study involving a large sample size of participants, thereby also allowing the researchers to capture variations of individuals' personal experience of aromas and taste in isolated settings. Lowe says the findings show that spatial perception played a significant role in how people smelt aromas. And this complements the results of other studies on the topic of astronauts' eating experience in space, including the phenomenon of fluid shift. You see, weightlessness causes fluids to shift from the lower extremities of the body to the upper parts, and this creates facial swelling and nasal congestion that affects one's sense of smell and taste. The symptoms typically begin to disappear within a few weeks of being on board the space station. But despite that, astronauts were still not enjoying their food, even after fluid shift effects were gone. That suggests there's something more going on. Former astronaut instructor and co-researcher Gail Isles, also with RMIT, says that despite carefully designed diet plans, astronauts aboard the space station were simply not meeting their daily nutritional requirements, something which is dangerous on any long-term mission. And with upcoming manned Artemis missions likely to involve long-duration space flights, especially when people go to Mars, that presents a serious concern. So scientists need to understand the problems with diet and food and how crew can better interact with their meals. Lowe says the study's results could help personalize people's diets, especially in socially isolated situations, both on Earth and in space.
It is well known that astronauts do not enjoy their food in space. We've seen this in the literature, which suggests that astronauts do not actually meet the 100% of their nutritional requirements. So what we are trying to do is to try and kickstart this in Australia. So we don't have enough size budget. So we're just thinking, how can we get this started? And one of my particular interests is on understanding how the eating environment itself could impact on how people choose different kind of food. We have seen this in sensory and consumer studies that they found that if you eat in different environments, that may yield very different responses, especially when you're eating in more quiet eating eating environment. So we're trying to replicate this in a space-like eating environment. If you think about it, International Space Station kind of feels like when you are in a confined, locked-up room. So we replicated this using virtual reality, and we're trying to understand if people smell different types of fruit differently.
When I talk to kids about being an astronaut or something like that, first question is, how do you go to the toilet in space? Every kid wants to know that. And the second question is, what sort of foods do you eat in space? That's changed a lot over the years. From originally, astronauts simply ate pastes because the paste would stick together and it wouldn't float around. Nowadays, they have a far more varied diet, but it still doesn't taste good, and that's obviously a real problem.
Yes, it is. It is a real problem because it means that if you look in the literature, most missions are about 6 months, or some of them go up to about a year. What we don't know actually is what happens beyond that, because if they are all not meeting the nutritional requirements, it's okay in the short term. We don't know what happens in the longer Mars mission. We don't know what happens to the human itself. So there's a need to look into, is there a way that we can encourage them to meet the 100% nutritional requirement?
We know that when you're in space, fluids rush to your head. Astronauts are always complaining they feel like they've got a head cold, even though they don't. And I always thought that might be the reason why foods don't taste good. But your studies show it's more psychological than that. It's the environment they're in that makes them feel closed in.
Yes, it is. So we know that the body fluid, it rushes to the head. It's sort of like you're having a cold. So when you're having a cold, it blocks your senses of your ability to smell, so you're only tasting the food. So that's why when we're having a cold, food normally doesn't taste good because you're only tasting the 5 flavors, like the 5 tastes, essentially.
Yes.
So what happens is that it's also found in literature with the body fluid movement. It's suggested that after 4 days to about 2 weeks, the body should do the job to be able to regulate this. But what we've seen in the data, like if you look in the papers on nutrition research or space, they're still not eating food in the 6 months or longer term mission. So it suggests that there's something else going on there. And it's not just the body fluids will play a factor, but what we are interested in is to understand what other things are happening in there.
And this is where the idea of improved smell comes into the whole thing.
Yes. We actually just started with smell. Our research group is also looking at taste as well. Smell is easier to replicate virtual reality as a start, but eating is really a combination of taste, smell, texture, and everything else. Yeah, so it's very interesting that we found this.
Tell me about benzaldehyde.
So what we found when we're looking at the data, we put people in different environments like the virtual reality space-like environment versus a control environment. It's quite interesting to see that certain food aromas were more intense. So what we did was then we did a chemical analysis to try and figure out why. What we found was because the food aromas are very complex. There's a lot of aromas in there, but there are some similarities between two of our aromas, which were also more intense when people are in the virtual reality. And what we found was this common aroma called benzaldehyde, which is normally a sweet-like compound, which is common for both vanilla and almond. So we found that they were more intense. Something that's more intense doesn't necessarily mean that they may taste good. It just means that in that environment, it may be slightly more pronounced. So maybe that may suggest that some people may not like their food in space. We had a reasonably large number, 54 participants. So normally in sensory science, if we want to look at differences between people, we need to look at about 30 people to see the individual variation because we are all different. And this is what we did. We ran the studies. We duplicated in different environments to see what are the differences in these different eating environments.
And what did you find?
We found that in the space-like virtual reality environment, participants were quite engaged in that environment, and they reported a low to medium intensity of loneliness in this environment. And that's kind of expected because these are healthy participants. So to be able to induce them to a low to moderate feelings of loneliness, it means that this could be a good measure to try and understand what's going on. And we also found that in this virtual reality environment, certain aromas were more intense in comparison to a control environment.
Were you surprised to find the psychological impact being as strong as it was? The fact that putting on the virtual reality headset made a difference?
Yes and no to that, because what I've been working on before this, our research team looks at more normal eating environments, like day-to-day eating environments, like eating in a cafe or eating, some people look at eating in the bar in comparison to like a standard sensory booth type environment. It's found that emotion do play a big factor in what food we tend to choose and how much we like certain foods. And emotion is something that is influenced by the eating environment itself. So duplicating this to obviously a space environment is more extreme. So we were expecting to find some differences, but it's quite surprising for us as well as a start when we're running pilot studies to see this. That was on a much smaller sample, and we actually duplicated this to the 54 people that we are running, and we found consistent findings.
So that's telling me that the idea of a romantic dinner in a fancy restaurant is really a good idea, but it's also telling me that eating in front of the telly is not as good as eating in a family setting in the dining room.
Yes, exactly. That's what we're trying to get to. And it's something that in the sensory science world, they've been looking at this, whether how different eating environments may impact on what we feel about the same food, and eating is contextual. So, for example, if you think about a sandwich, if you eat a sandwich in a scenic park on a spring day, it feels very different when you're scoffing down the same sandwich in front of a hotel.
Where do you want to take this next?
So we are looking to actually combine this with different body postures. So that's looking at the body fluid movements and to combine it to the virtual reality to see if there's an added effect. And that's something Grace Lowe, which is the first author of this paper, my PhD student, is running next as well.
Now, this isn't just applicable to space. This can be used in all sorts of settings, places like nursing homes and hospital settings as well.
Yes. So we are only at a fundamental stage to try and see if there's a difference, in this more extreme light eating environment. But yes, if you think about it, the space light eating environment, it's very similar to a nursing home in the sense that people are confined. You're only looking at a couple of people that you're looking at. There's a very limited menu as well. So there is similarities that you can draw to other people living and working in this environment.
That's Julia Lowe from RMIT University in Melbourne. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study suggests that close to 5% of people are consuming products that are potentially toxic to their livers. The findings, reported in the Journal of the American Medical Association, are based on a survey of close to 10,000 people across the United States. The researchers found that 5% of people reported consuming either turmeric, green tea, ashwagandha, Garcinia cambogi, red yeast rice, or black cohosh products. The people who use these herbs tended to be significantly older, better educated, and more likely to have arthritis than other users. The authors warned that clinicians need to be made aware of the toxic liver issues that could arise from these mostly unregulated products. A new magnetic robotic glove has been developed by scientists to help people who need hand rehabilitation. A report in the journal Device claims the glove can solve problems with current options for hand rehabilitation, which are often costly and impractical. Engineers developed the glove to provide resistance by way of magnets, which can be used during exercise to help people regain strength in their hands. They say the gloves are inexpensive, customizable, and portable, allowing patients to use them both in a clinic and at home. The new gloves could help patients stick to their rehabilitation exercises more consistently, which would then improve their overall quality of life. A new study has found that your social position, including your job and income, is linked to your food preferences. A report in the British Medical Journal looked at the food and drink purchase records of 1,521 households, both in London and in the north of England. They analysed how people made daily food and drink purchases, as well as their self-reported use of food delivery apps and prepared takeaway meals. They also collected data on other factors, such as social position, income, and body mass index. The authors found that those in the lowest so-called social grade had more than double the odds of using food delivery apps compared to those in the highest group. And while there were no associations between weight and online grocery shopping, those who used food delivery apps were some 84% more likely to live with obesity and 45% more likely to be overweight compared to those who didn't use them. And the British results aren't unique. Similar results were also reported in Australia. While the study is observational and therefore can't prove cause and effect, the authors suggest grocery purchasing may depend on financial resources, while takeaway purchasing could be linked to culture and social groups. Food delivery apps could also be making it easier to make unhealthy food choices and therefore worsening health inequalities. The editor of the pop paranormal website Higgypop says he's a skeptic and the many ghost hunts he's been on haven't changed his opinion yet. Tim Mendham from Australian Skeptic says the editor's findings mirror his own experiences on ghost hunts and those of other science-minded investigators.
This is an article written by the founder of the Higgypop paranormal website. It has a lot of interesting stuff and case studies and things, but it also has a lot of skeptical comments. And he said he's been on 100 ghost hunts, actually 101, in 71 different locations, a lot of them high-profile ghost hunting sites. And he says, and I'll quote him, "I'd experienced the same stimuli and psychological cues as the ghost hunters. I was sure I would experience the same things as those who reported paranormal activity at these places, even if it wasn't caused by the spirits of the dead. But exactly 101 investigations later, I've had none of this. Where are the creaking floorboards and the tricks of the eye, the doors slamming in a draft? It makes me wonder, what are these ghost hunters experiencing that they could be mistaking for the paranormal?" So he's basing it on his own experience, that he's done all these ghost hunts in often high-profile places at the right time, places where there's supposed to be hauntings reported every week, etc., and he goes there and sees nothing, and sees nothing, and sees nothing, and sees nothing. There's a few interesting events he's had, but he doesn't regard them as highly significant, and that perhaps they could be explained with further investigation. So he's a proponent of this stuff. At least he does promote the proponents of ghost hunting, etc. And he suggests that there are 4 ways that ghost hunters often use, technology especially, that to find their ghosts. One is what's called spirit boxes, another is electronic voice phenomena, EVP detectors, word bank tools. These are all sort of little handheld devices that you can use to test for ghost presence and, of course, personal experience.
These are things that go beep.
The things that go beep. And a lot of them are just frequency rangefinders, or they just whiz across through all the frequencies, and when you come across a weird crackling sound, that's obviously a ghost. EVP are the same sort of thing. Electronic voice phenomena, but they're not necessarily voices. It could just be crackle and static and all sorts of things. And often that's when you play back afterwards. You don't hear it when you're there, but you play it back afterwards and you discover, oh, that sounds interesting. So there's a bit of cognitive bias in there. Word bank tools are similar, where they affect a word generator. Well, the question is about all these things is, can ghosts interact with technology as these things are supposed to indicate? You know, and that comes down to, what is a ghost? Is it an ethereal thing? Is it a physical thing? Can it actually do things like knock vases off mantelpieces? Or does it just wander around, etc., being ghostly? Personal experience is as much in the eye of the beholder as anyone else. He's been to these things. He hasn't had any personal experiences, and he knows, okay, that maybe he has to spend another 100 ghost hunts, whatever. But doing 100 is pretty good, pretty decent investigation, especially one particular haunted site, supposedly haunted site. He spent 40 hours in all up, and yet still didn't see anything. It can be sort of not good for your social life. I've been on ghost hunts. Most skeptics of a certain sort of level, if you like, have been on ghost hunts.
The perfect ghost hunt is one at a haunted pub.
That's exactly right, where there's a lot of spirits. And it's amazing how often, this is an interesting phenomenon. It's amazing how often old pubs in the UK are haunted. And you think, why? Is it the spirits, or is it because these pubs want a bit of publicity and to get people to come along, to actually have a few drinks and watch a glass fall off a counter?
The glass falls off the counter because the counter's just a little bit wet, just wet enough to cause a loss of friction. And there's a wind or something blowing.
You're just a spoil sport. It says ghostly. The ghosts are like the cats of the spirit world. They just like to walk along and knock things over.
Well, that's the proof why the Earth isn't flat, because otherwise cats would have knocked everything off.
Yes, that's right. Yes.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.